Today's lesson you'll be learning about unit rates and proportional relationships. So in the first example, fill out the table. Jeff hikes 1/2 mile every 1/4 of an hour. If you complete the table with the missing distance to find out how far he will walk in a 1/2 hour, 3/4 of an hour, 1 hour, and 2 hours. So it looks like the relationship here, going from here to here, we have added a 1/4 of an hour, and then added another 1/4 of an hour, and then added 1/4 of an hour. This one's a little tricky. Pay attention to the increment because you actually have added 1 hour. So let's look at the distances. So if his rate is that he travels 1/2 a mile in a 1/4 of a mile, 1/4 of an hour, then how far will he have traveled in a 1/2 hour? If you came up with 1 mile, you are correct. And then again, we're adding to that, because the same increment of time, a 1/4 of a mile, we're adding a 1/2 of a mile, and another increase of a 1/4 of an hour would add a 1/2 a mile. And here's where it jumps, because now we've added a complete hour, and so his distance is 4 miles, because we doubled the time, so we doubled the distance. So what this brings about is that we need to define what the rate is. We've been talking a lot about ratios, and so a rate is a ratio that compares two quantities with different units. And we've encountered this already with our scale factors. So I'm just going to fill in the table again for you up here. So you have that. And then a unit rate. So we talked about a rate. It has different units, just like our miles and our hours. So that forms a rate. And the original rate is 1/2 of a mile for every 1/4 of an hour. The unit rate is a rate with a denominator of 1. And so hopefully you can identify the unit rate in this situation. And we would describe it as Jeff traveling 2 miles per hour. And so miles per hour is a unit rate, and one that we're very familiar with. So this brings up the idea of complex fractions. We've talked about this a little bit this year already, because we've already done division with fractions. In the case of a rate, like miles per gallon or things like that, sometimes you have fractional quantities. So we have to know how to deal with those. So in this case, to find the unit rate, you are going to divide top and bottom by the denominator, right? To simplify each complex fraction, you basically want to use division. This is implying 2/3 divided by 1/4. So we would write that out in a way that might help us see it a little bit better. And then we would write it as a multiplication problem. And then you can leave it improper, or you can go ahead and change it to a mixed number. And again, if this were a unit rate, it would have units and labels. Okay, so again, a complex fraction is just a fraction divided by a fraction. Okay, so 3/5 divided by 2/3 is 3/5 times 3/2, which is 9/10. Let's leave it as a fraction is fine. All right, in example 3, Paige mows 1/6 of an acre in 1/4 of an hour. How many acres does Paige mow per hour? They're asking for her unit rate. So again, we have this 1/6 of an acre. Here's our units now because we have a problem with a context. 1/4 of an hour. And basically, we want to know the missing number, right? What is that number? So you can find that a lot of different ways. You're going to be basically dividing 1/6 by 1/4 to find that. Work would look like this. And then our answer is actually a fraction, that she would mow 2/3 of an acre per 1 hour, or per hour. Okay, so this 2/3 would actually be a fraction in place of the x in the numerator there. And so we have to get used to seeing it that way, and it's okay to leave things as fractions instead of changing them to decimals. All right, example 3. 2 liquid storage containers are being filled. Liquid enters the first container at a rate of 2/3 of a gallon per 1/4 minute. Liquid pours into the second container at a rate of 3/5 gallons per 1/6 minute. Determine which container is being filled faster. So in order to compare this and problems like this with unit rate, you want to calculate the unit rate and then compare those unit rates. So we want to know per 1 minute for each of them. So the first container is 2/3 divided by 1/4. We have already done this in our first example with complex fractions. So we have 2 and 2/3 gallons per minute for the first one. For the second one, we have 3/5 of a gallon per 1/6 of a minute. So that's going to be 3 and 3/5 gallon per minute. And once you have them both in the unit rate, which one is greater? And the one that's greater is the second container. So second container is being filled faster. Another place where it's commonly where we talk about things is we're looking for the lowest price of an item in a grocery store. Take it down to the unit rate to find out how much it is per ounce, per, whatever measure of or size it is. Then you can determine which one has the lowest unit rate to see which one is the better buy or the better purchase. All right, proportional relationships. This is going to be a new concept for you. I'm not sure if you've learned this last year. So in a proportional relationship is a relationship between two quantities in which the ratio of one quantity to the other is constant. You can find the constant of proportionality by dividing the ratio y divided by x. A lot of times this is the scale factor, and we have worked with this a little bit this year. The equation for proportional relationships can be written as y is equal to a times x. And in this case, this a is called the constant of proportionality, because if we solved both sides of the equation for a, we would be dividing by x. So y divided by x equals a, And this is that scale factor or that constant of proportionality. And so we'll be using this information in the next example. So we're going to tell if the relationship is proportional, and if so, give the constant of proportionality. So in a table situation, you want to determine, and most of them are set up so that x and y, okay, you could use division. And so what we have to see is that at each place along in the table that the ratio is constant. So the ratio of y to x, okay? So 9 divided by 3 equals 3. 15 divided by 5 equals 3. 21 divided by 7 equals 3. And 30 divided by 10 equals 3. So is it proportional? Yes. Give the constant of proportionality. A would be equal to 3. Let's look at the second one again. So 40 divided by 10, 95 divided by 25 is 8. And then we notice that this is also right here, just by doing these two, are not a constant rate. Therefore, it is not a proportional relationship, and we cannot give the constant of proportionality because the rate is not constant. Write an equation and tell what the variables are representing. In this case, Gloria earned $26 for babysitting for 4 hours. So we basically want to know what is her hourly rate, right? That would be the constant of proportionality in this case, because how much money she makes is not going to change, right? Whatever they pay her per hour, whether they're paying her $1 an hour, $10 an hour, or whatever it is, that amount is the same. We call that the independent variable, and that's the x variable. So our x variable is usually independent. And then our y variable is dependent because it's going to depend on whatever x is, okay? So in this case, the constant is that constant rate. In this case, 4 is our x variable because the number of hours, right? That's just measured in time. It's not going to change. But the dollars we make will depend on how many hours we babysit. So first we must find out that y to x to see what that constant rate is. That's going to be our constant of proportionality. So 26 divided by 4. You could set it up as a table. And then we could also set this up as an equation, right? Because we need to know what a is equal to. So our equation, after we figure this out, this is $6.50, which is our constant rate, right? She's making $6.50 per hour, that unit rate. We need to write an equation and then determine how much she'll make in 25 hours. So now that we've determined this constant rate, our equation is going to be, because x would be the number of hours, so to tell what the variables represent, x equals hours, y equals dollars earned, okay, y is equal to this ax, okay, so since we've calculated a, that's this number right here, through that ratio, we have y is equal to $6.50 times, if x were 25 hours, she would have earned $162.50.